Weli wela do, obin wala pang, obin wala pang,
The rocket stove is a wonderful invention to help poor people. It burns half of the fuel wood of an open fire, and of that half produces half of the emissions. And that's a conservative estimate, maybe even better than that. One problem with the rocket stove is that it's so hot, it burns itself up. The metal combustion chamber will not withstand the high temperatures that are necessary to get good combustion from the wood. As a result, we realized we had to make the combustion chamber from ceramics, but they couldn't be heavy. If you use a regular brick or even a regular mud, this happens to be half-fired, but whether it's burned or not, this is very dense. And if one side is hot and one side is cold, the heat will pass right through this. The heat will be robbed from the fire and poor combustion will result. Also, your goal is to cook food and to put heat into the food, not to put heat into the stove, not to put heat into the air. We don't want to heat a 30-pound stove in order to cook 3 pounds of food. So the solution is to make an insulating brick. We realized we had to invent a lightweight ceramic that the heat would not pass through. We learned that if the brick will float on water, it has enough little pockets of air to keep the heat on the hot side and keep the heat into the combustion, keep hot combustion, and not absorb heat from the stove. So our test at the moment is, will it float? And we'll put it in this bag. That will keep the little holes, the little air holes in the brick from filling up with water, because the brick is very much like a sponge. If it gets wet, it will soak up water and sink. But you can see that this brick will float. If the brick was even lighter, it would be better. But if it's lighter, it's more fragile. Our goal is to make very inexpensive stoves. And we realized that in order to make a lot of stoves that will really make a difference in the world, they have to be mass-produced and they have to be very inexpensive. And in many places of the world, we have brick makers, and they already know how to make bricks. They already have a clay source. They know how to burn bricks in a kiln. And so if we can teach them to make these special bricks, it will be an easy transition to doing this. It took us a while to invent the trapezoidal shape of the brick. And we've labeled this the 6-brick stove. Right now I'm going to demonstrate an experimental mix. It's important that we experiment with mixes because every place the clay is a little different, the ingredients are a little different, the texture and coarseness of the ingredients is a little different, and if we don't experiment, we don't know. We've been using rice husks. These are full rice husks, just as they're milled from rice. It's good because basically they're free, but we've used about 20 different kinds of organic material successfully in bricks. Everything from ground up coconut fiber to ground nut shells and many, many things. But today we'll make some test discs using 3 ingredients. The rice husks. These are rice husks that have been slightly ground. You could grind them in a hammer mill. These were ground by rubbing them together between boards. You could use standard stone and pestle mill, many ways of doing this. But keep in mind we need to have a very huge volume. So whatever we do, we need to grind a very large amount. This is rice bran. It has commercial value. It's fed to animals. It's probably the most nutritious part of the rice. Humans really should be eating the bran and not the kernel, but we're just doing it today as an experiment to see if the rice bran will work. These 3 things are all from rice, but they're different coarsenesses. And it may be that 10 parts of this is not equal to 10 parts of this. And the way to discover this is to make test discs and examine them when they're done. So what we'll do, we'll take and we'll make a measuring tool. And brick makers in the world historically measure things by volume and not by weight. First, I'm going to cut this. I've scrounged this empty water bottle. You can use many different kinds of things, but I'll cut this off fairly high. I'm going to cut it again in a minute. And then we want to find out where 10 parts come on this. So we'll use this to measure 10, and we'll use this to measure 1. And then we can add and subtract 10s and 1s to get various mixtures. So I'm going to first do this with water. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it comes to about that line right there. So I'm going to cut it off right where it comes to 10. I'll just dump that out for the time being, since I have my mark. And another way you can do this is to take a small board, burn a hole in it with a piece of charcoal, scrape out the charcoal and make a little measuring spoon. Right at the moment we don't have a board and we do have a bottle, so we've decided on the bottle. Now, just as a double check, let's see if 10 parts of this come up to one part of this, if 10 of these come up to one of these. And you have to be sensitive to how much you're tamping it, how much you're packing it. But you want to think, what will the brickmaker do when he's mixing wheelbarrowfuls of this? So there's one, and now since it's wet, it's going to be a little sticky. This is not exactly laboratory science. We're looking for approximations. 3, 4, 5, 6, 7, 8, 9, 10. So we're off a little bit. We're off maybe as much as 20%. 1, 2. So I'm not sure whether we'll accept that for error or not, but for the time being, if we were using measuring tools that were slightly bigger than this, the error would be smaller. But for now, I guess we'll just go with this error, and we'll keep it in mind that we measured 12 brands. Let's measure the coarse rice husks and see how many of those we get. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's come out pretty close. So we need to make a note that we have a little error in how much we've measured. If we were weighing it, we may come up with slightly different results. We know about 10 to 10 or 12 parts, maybe even 14 parts of organic material to 10 parts of clay. So we'll use 10 as the base, this being our 10, and we'll measure out some clay. Now, I'll say something about the clay. We just dug this clay up and it's not really mixed very well, so there are lumps in it. By the time we finish mixing it, we should get all those lumps worked out, and we should get them all worked into the organic material so we don't have lumps. We'll put different parts into 10 parts of clay. So if we make 8, 9, 10, 11, 12, 13, 14 parts of organic material into 10 parts of clay, here's 10 parts of rice husks to 10 parts of clay. Here's 10 parts of rice husks, but now I'm going to subtract 1. And the rice husks are so coarse that it's hard to get this really accurate at this small scale. So this, if you make your containers a little bigger, it'll actually be better. So this is 10, and this is 9, and this one's going to be 11. So there's 1, and here's 10, so that's 11. And then this one will be minus 2. So this will be 8. Let's see, 10, 9, 8, 11, 12. So there we get 12. And now 13. 1, 2, 3, and then 14. 1, 2, 3, 4. Okay, now since this is our first batch, we'll put 1 dot, and that will stand for rice. So when we make our record, we will know that 1 dot stands for R, or rice, and that means unground rice husks. And then this had 8. This had 9. Pretend I'm a dot matrix machine. This had 10. This had 11. This had 12. This had 13. This is 14. Get my one dot back here at the bottom again. Okay, now we'll start over again with the ground rice husks. So these rice husks have been ground more or less by hand to about maybe half the consistency. Now you can try different grinds. You can try mixing these with whole rice husks. You can try mixing these with sawdust. You can try anything you think will work. If you think it will work, try it, and then you'll find out. So here are our test discs. This first row are rice husks. The second row are rice husks that have been ground, and the third row is rice bran. Every disc here has 10 parts of clay, but we've varied the amount of organic material between 8, 9, 10, 11, 12, 13, 14 parts, and the same with each of the other rows. So this disc will be a little more dense than this disc, and because we don't know how the fineness affects it, we will find out when we burn these discs. We'll do a will it float test. We'll see if they'll float. We'll see if they're fragile, and we'll be able to choose which we like, and we'll learn something from this test. We don't have to have perfect results. We don't have to have perfect mixtures. This will give us an indication, will lead us to the next test. We'll be able to say that maybe this mixture came out really good, and we know that if we put some ground up rice husks into whatever we're doing, maybe it will help it. So we'll try that. Each time we make a kiln full of bricks, or each time we do a test, we should have some variables. And like any test, you want some of them to be failures. You want some bricks to not float, you want some bricks to crumble. If you don't have that range, then you know that you haven't tested the limits of your mix. But someplace here in the middle, we'll find a brick that floats and that it's strong. And then we'll use that test disc to actually make some test bricks. So the next step is to let these dry for a while, preferably until they're completely dry. But usually we're in a hurry, and we'll let them dry for a while, and then we'll heat them slowly and get the rest of the moisture from them. But the best thing to do is to let them sun dry, turn them over, dry them slowly, maybe even dry them in the shade. All this will give us some information about the bricks and the way this dries and the way the clay shrinks just as it dries. Once they're dry, we will make a little test fire, probably from charcoal, and we'll put these in the charcoal fire. We'll cover them with something to keep the heat in, such as rice husks work very, very good, or grass or straw or sawdust. And then these will burn at a low temperature, not unlike a low temperature kiln, and we'll be able to see how they come out. So that'll be the next step. I bought this bundle of grass from a lady for 1,000 shillings. Everything here is wet. Our rice husks are wet. Our grass is wet. This is the rainy season, and we're constantly fighting moisture. But I decided I would buy this bundle of grass and I would add it to the top. It'll add some extra heat. Also, the ash will insulate the discs, and it'll hopefully keep getting hotter and hotter. Even though we had a relatively horrendous fire, we didn't succeed at even burning the charcoal, the carbon, out of these test discs. So now we're trying again. And we have an improved fire this time. We're using dry charcoal. We have a draft. We have air coming up underneath. And as a result, we have a very hot, good fire. And we have dry test discs. So we'll put these discs in the fire, and hopefully this time we'll be more successful. Now, the idea of testing things is to learn something. So by studying along the way, you will learn different things about your clay and about burning and so on. Some of our volunteers made these little pots just for fun, and they made them from pure clay. And if you look in the bottom, you'll notice they've cracked. This is just in the drying process, and it means that they haven't grogged the clay enough with some filler. Now our bricks, because the structure is opened up by the organic material, it helps that from cracking. But if you make test discs and they crack when they're drying, then you know you're doing something wrong already, and you can keep experimenting. So the thing that they could learn from this is that they need to make something with their clay to keep it from shrinking so much. So we're still going to burn these and see how they come out. If we're going to successfully burn these discs or bisque them, we will have to keep the heat in, and we'll have to insulate them somehow. And rice husks are free to us, so we'll start putting rice husks on here in a few minutes. This has been burning for a couple of hours now. It's burned down. It's probably finished, and we're going to push the barrel over and take the discs out so they can cool and we can inspect them. So this is a bottomless barrel with some pieces of metal that have held up our discs, and we've got some good burned ceramics now. Well, these will cool relatively quickly if we get them out of the insulated rice husks. That's a rock on the bottom. We've successfully burned these discs. You can see they've turned orange, looking like a brick, and they've cooled. We've just taken them out of the fire. Now, to recapitulate what we've done here, this first row are made with rice husks. The second row are made with ground up finer rice husks, and the third row are made with rice bran. These are numbered 8, 9, 10, 11, 12, 13, 14. That means that there are 10 parts of clay and 8 parts of organic material, 9 parts of organic material, 10, 11, 12, 13, 14 parts of organic material. So you would think that these would get lighter and lighter, but actually each of these discs weigh about the same because they each have about 10 parts of clay, but the volume increases with them. They're all pretty strong. The ones that are down in the 9s, the 8s and the 9s, should be stronger, but they should be heavier. The ones up at the 13 and 14 should be more fragile, but they should be lighter. Some of them didn't burn very well because of our primitive fire, but that happens. Some were around by the edge. This one isn't burned very well, but it will at least tell us about how the organic, about the density of it. So now we do what I call will it float? And the question is, will this disc float on water? We have to put it in a plastic bag because it will soak water up like a sponge. If we put it in directly, it'll just sink and the air bubbles will come out of it. But if we put it in a baggie, we don't want to fill the bag with air because we're trying to see if the disc will float, not whether the baggie will float. But you can see that this disc that's number 8 will not float. This is the clay and rice husks. Now yes, the clay and rice husks. Now this is disc number 8 that is clay, and ground up rice husks. And it just about wants to float, the number 8. The number 8 rice bran it wants to float. So even though we've used 8 parts of each of these ingredients, there's a difference because of the texture in the organic material. Now 8 didn't float with rice husks. 9 got a kind of an air bubble in there. It doesn't quite float either. Let's try 10. 10 doesn't quite float. 11 looks like that's going to be the first one that will float. 12 floats real good. And so we can surmise 13 and 14 will probably float. Now, because of the small volume of material and the inaccuracy in measuring, you can have some inaccuracy with this. So you might find 12 floats and 13 doesn't float just because of accidental mixing. But so far, we see that all of these ones lighter than 9 are floating. What this tells us now, we want to look and find a disc that's good and strong, preferably one that rings like a bell and doesn't just go thud. These are all kind of thuddy, but that one is ringing a little bit, but 9 won't quite float. Also, we could step on them, we could drop them, we could do various tests to see which ones are stronger or which ones are weaker. But they've all come out pretty good, looking pretty good, and they'll all make good bricks. In fact, the way we're making bricks right now is about 13 parts of rice husks, or actually mostly now we're using sawdust. We found the sawdust works a little better than the rice husks. I'm not sure why that is. I personally like rice husks, but that's just a bias that doesn't stand up in the laboratory here. The sawdust is proving to be better at the moment. Now, sawdust costs money, and rice husks are free, so this may influence us in the future. And it's one of the reasons we did this test, to see if ground up rice husks will work better. And I believe they do. And we'll study these a little more carefully and see what we think. This will suggest other tests for us in the future. One thing that we did, we made a few just wild card ceramic pieces. We did this by experimentally mixing things. This is very lightweight and not too bad looking. I'm sure it's going to float. It actually floats quite high in the water. We were experimenting with mixing in a different manner. We took clay slip, and we kept making the slip thicker and thicker until it was just about to gel, and then we put rice husks into the clay slip rather than mixing it dry or drier and harder. And the future of lightweight ceramics involves mass production. If we can't mass produce these, we can't build thousands and thousands of stoves. So we're constantly looking for ways to make these faster and better.